Hi everyone, and welcome to FOSSi Dial-Up. This is another edition in our series around evolving communities. And the project that we are talking about today is Cocotb, or wrong direction. It's a project under the umbrella of FOSSi Foundation, but it's driven by a large community of maintainers. And one of the lead maintainers is here today, which is my colleague on the board of directors also. Philipp, hi, how are you?
Hey, good, thanks.
Nice to have you here. Let's jump right into the presentation. As always, please drop your questions in the comments and we will speak about them after the presentation. And yeah, please subscribe to the channel. So thanks for presenting, Philipp.
Great, welcome everybody to this FOSSi Dial-Up talk. I'm excited to be here and I'm excited to talk about something that was and is for a couple of years now part of my life, is taking care of Cocotb. And today we will be looking back and looking forward to how Cocotb, how it evolved and how it kind of came into the place that it is in today. To start with a very quick preamble, Cocotb is based on a principle that verification is software. So that is, if you're kind of coming from a very wild world, just to catch you there. So we're talking about verification of hardware, verification of designs that run on ASICs or FPGAs, and we want to test if they're actually doing what they should be doing. That's the job of verification. And normally, in many environments, verification is done in UVM, that is System Verilog effectively, plus a class library. And Cocotb offers an alternative to that. And it offers an alternative in that it is giving you a different library to write those tests in, and you do that in different language, Python instead of System Verilog. And combining all those things gives the verification engineers a very, very productive and actually fun to work with verification environment. So if you have never heard about Cocotb, I'm gonna be sorry that I'll have to leave you effectively with this very quick intro into Cocotb itself. There are a fair amount of talks and interesting tutorials out there in the internet that you can just have a look at and learn more about Cocotb, and then jump like on our Github channel or jump into Github if you have a question. What we'll be talking about today is something else. It still relates to Cocotb, obviously, and one of the things that Cocotb is, it's not just Python and it's verification and it's productive, but it's also open source. It is free to download, it is free to use, it is free to modify, it is free to even sell. So you can do with Cocotb whatever you want. The thing is, it's kind of, if you just look at it this way, it's a one-way street effectively. One thing that isn't free is maintaining Cocotb. Doing so is actually a rather expensive in terms of time and also money at times undertaking, and that's what we will be looking at today. We will be looking at how we maintain Cocotb today. And there are two aspects to that. The first is the we aspect, and I'm part of that, but only a small part of it. And we'll see in a minute, or in a couple minutes actually, how Cocotb is maintained by a rather large community these days. And we'll be looking at today aspect. So what do we do today to maintain Cocotb? But we will also have a look back. We will be looking at the things we have learned over the time and things we have improved and changed in the way we maintain Cocotb. So before we dive into all of that, let me quickly introduce myself. I'm Philipp, I'm co-maintainer of Cocotb, and I'm software developer, hardware developer, sysadmin at times, with kind of interests all over the place. That is very unspecific and keeps me busy because I always find interesting things to work with and at. I'm director at the FOSSi Foundation, just like Stefan. I'm in my day job hardware and software engineer at Low Risk in Cambridge in the UK. And before that, I have been doing a PhD in Munich, where I did work on a topic very close to the hardware and software boundary, going back into the theme of working with hardware and software. I was working on trace debugging there. So you can find my contact details there, but I guess Google will find those for you as well. Enough about me. Let's dive right in, and let's start with kind of the history of Cocotb. So Cocotb started in 2012 and was kind of the two people that were behind it mostly were Chris and Stu. They open sourced then Cocotb in 2013, and kind of the early code of Cocotb was partially driven by needs of some in-house projects that we're working on, but there was always a clear idea that the Cocotb, the things that they developed, would be useful beyond what this particular in-house use case was. So Cocotb was successful from very early on, not just for a very particular project, but also for a wider set of projects. And people got interested in it because it was and still is filling a very interesting, at that time, niche, but it's becoming a larger part of how we verify chips. And it started the first public release in July 2013. Already interesting back then, Cocotb did already support 3 simulators. One open source simulator, that's Icarus Verilog, and 2 proprietary simulators, that's VCS and LDEC. So right from the start, Cocotb was showing the kind of one of the main core strength that it still has today is the ability to abstract away simulators and give you as a verification engineer a productive work environment without worrying about the details of a particular simulator, and giving you freedom of choice in choosing whatever simulator is best to run your design on. So if you have never used Cocotb, maybe one very quick word on how Cocotb works. So Cocotb is, as I said, doing the verification. So the verification, the test code is written in Python, while the design that you test, the design on a test, is typically written in synthesizable VHDL or system Verilog or normal Verilog, and runs in any simulator that is supported by Cocotb. So for example, your design, your chip is simulated in an Icarus Verilog or in VCS, and your test is then written in Python. So Cocotb provides this bridging between those two worlds. And things were moving quickly. So we did have that first release in 9th July. Only 10 days later, there was a second release. And obviously, robustness got improved as you would expect initially. And yeah, roughly, I think a couple months later after the summer break, we did a third release. And then in spring of next year, there was a 0.4 release. So that's February of 2014. And then a year later, February 2015, there was a 1.0 release. So kind of the first release that got designated as potentially not stable, but at least a major milestone that was worth celebrating. So there was added FLI support. That's a way to talk to model sim or Quester simulators. There was for the first time the ability to do mixed language, Verilog and VHDL designs that are written in Verilog and VHDL, and actually run Cocotb against those. And there was first initial Windows support, which is interesting on its own. And there was a lot of performance improvement and things beyond that. Windows improvement is interesting and important to mention because it, for the first time, was a major feature that the authors of Cocotb didn't have a use for on their own, in their own kind of daily life. They were using Linux, as many of us are doing, and Windows support was contributed by people outside, just added through a pull request, but never really something that the core maintainers were interested in or could test or help with development. So this is kind of a first example of if you open source something and show it to the wider world, you'll get contributions that you haven't thought about. And your project might expand into areas that you didn't think were interesting for you particularly. But you still, in the end, if you merge those things in, you need to maintain it somehow. You need to take care of it. You need to potentially help users that are now using Windows and say, oh, Cocotb doesn't work on Windows. What do I do? So what do you say? I have no idea. Things like that. So these are questions that need answering. And the more popular a project gets, the more of those questions will arise. And Cocotb was and is very, very active and very popular. So if you look at the graph on the left, you see obviously the initial set of commits. So this is number of commits over time as GitHub shows them. And if you look to 2013 and 2014, in 2015, you see always kind of spikes of work and a bit of quiet phases in between, also in the beginning of 2016. And then it slows down as we go towards 2017. And this is kind of one of those defining moments for Cocotb as a project. And this is an experience that many, many projects in the open source world have had. And obviously not only in open source, but that's what we talk about. Same thing happens in proprietary software as well, is that at one point, things diverge. The interests of the maintainers and the interest of the wider community that is now using that project or that product. And the kind of the milestone or the defining moment was this issue that was created roughly 2 years after the 1.0 release, and no release has been done since. And that was asking a question, is Cocotb dead? And it came from the fact that there hasn't been a release for 2 years. Also, a lot of pull requests that people contributed and that weren't in the state of being merged immediately, or weren't something that the core maintainers actually needed at that time for their own internal projects. That's why they started. And well, obviously we're working on Cocotb. So these were out there. So the community, people were proposing to change things in Cocotb, but nobody actually had the time or any other kind of financial interest or things like that to help out and then change things. So effectively, a lack of time was driving the community apart. So what was happening is that while the main repository that Cocotb is developed in kind of was reasonably dormant, people were starting to fork and then create derivative versions of Cocotb that were useful for their whatever problem they wanted to solve. So just patch a thing here and then sort out something over there. But it diverged. So there was no one Cocotb anymore. And there was also no other place, kind of a alternative place that came up that now provided this central repository and kind of this central integration point. The original maintainers and authors of Cocotb did know that. So they did hear that and see that. But they were employed by a company to do verification work, actually, and not so much work on Cocotb itself. And as all of us know, time in the evenings and spare time is limited, and is really looking through pull requests that you actually are not interested in the thing to do and the thing to spend your time on, or do you potentially want to go to a pub, spend time with your partner, or things like that. And this is one of the replies that Stu on the top then gave. I think there's one sentence in there that's worth reading out. It's also well, we don't do that as a day job, but there also were years of commits that we have that we still need to upstream. So they also then developed and used Cocotb further for their internal projects, but didn't have time to actually upstream and potentially clean up and then generalize the kind of things that you need to do to then integrate them back. So things were diverging. And this was a time when we at the FOSSi Foundation got in contact with Stu and Chris, and we have known them for quite a while, how we can address that problem, how we can solve it. And the rest of the talk now will be roughly about how we overcame that challenge initially, and then how we brought the community back together. Because it's important to know, we were talking about Cocotb being free to use, free to download, free to sell. That's the source code that you can download, that you can use, that you can sell, that you can distribute, that you can modify. But the real value of open source, that's where the magic happens, is in the open part. And that's not about the source primarily, but the communities, the participation, the forum where everybody gets together to solve a problem that they have, and then throw together those solutions to form something bigger, to build on top of what somebody else has, to talk through ideas, to talk through solutions, to talk through problems. So this is a form of interaction that many kind of commercial, traditional approaches that deal with software distribution have a very hard time with understanding the user, understanding the needs of the individual developers. And it's actually a huge amount of effort and time that somebody needs to spend to understand what is really the use case, and then talking kind of beyond the manager and beyond the salesperson to actually the developer who has those pain points, to articulate them and come together to find solutions that make verification, which is the problem we are looking at here, better for everyone. So in order to be a successful open source project, you need to have that community. You need to have that open participation. And enabling that is something that we were looking into, and that's something we, and I'm proud to say that, managed to have again. So maintainers make that happen. Maintainers are enablers for that open participation, for that forum that everybody can join and participate in. But kind of in a general sense, the maintenance means taking care of the project as a whole. And that is a lot if you think about what actually it means, what jobs are there in a software project. Let's have a look at some items. User support. If people are using your software, your hardware, you will get support questions. There's issues that people create. These coming up in chats and mailing lists, in Stack Overflow in the hallway, where, for example, just a colleague asks you, how do you do that? And then you end up debugging something with them on a screen next to them. That's clearly not happening at the moment, but we've all seen that happening. It will happen again. There is a job of writing documentation if you don't want to tell the same story again and again. There's the project of getting releases out, doing release coordinating and project management. There's a bit of legal work that needs to get done, and we'll get to that in a second. There is fixing bugs, obviously, when people do raise an issue, and sometimes they can solve it themselves and sometimes they can't. So that's actually, something that needs to get done. Coordinating work. If you don't want to do it all yourself, you need to find somebody else to do it. And if two people want to work on a similar feature, you need to form a consensus, potentially, or help forming a consensus. There is the aspect of marketing and evangelism, giving talks, writing blog posts, tweeting about your stuff. Going beyond just simple features and simple fixes, there is obviously the job of designing new features, going beyond what Cocotb and in more general terms, which is often hardware does at the moment. So all these things are sometimes fun, but often boring, the maintenance. Now, at the bottom, there are two things that most people actually want to do in the end. It's write exciting code. It's doing the new and exciting things that, for me at least, give gives the most an enjoyment and actually doing things that haven't been done before. But that's, as we see, kind of very much at the bottom of the list. And then still use Cocotb in the end. We have a community in Cocotb, and that's something that we see a lot in an open source EDA and an open source hardware-related software. We have not that many people who are employed or have fun in only writing the tool. Very, very often, the tool is just a way to get a job done, a verification job done, or a chip designed. So that is still something we want to do. It's not just about a tool, it's about actually using that in the end as well. So these are all the things that maintainers could do. And I would argue it's not the thing that actually they should do all the time, or even must do. And that's kind of the core part of the problem that we saw is what maintainers have to do is enable and encourage participation to make sure that not all the tasks we have seen on the other slide are actually something just a single person has to do. It is possible to split up those tasks into the wider community and spreading them out, but that's only possible if there is participation from others, and this participation needs to be enabled, this needs to be managed, this needs to be encouraged. And how we do that in the Cocotb world and also takeaways that you can apply to your own project to do the same is something we'll be looking at next. So let's see how we did that. And it started here. And the timing was in the end of 2018. I was moving from Munich to Cambridge, and my apartment was still quite empty back then, and my partner wasn't here yet. So I actually did have a fair amount of time to code. It wasn't the most convenient work environment since I didn't have a desk. I just had a desk from outside. So I pulled that in, and since I didn't have anything else to do, I started going through the Cocotb backlog of pull requests for a fair amount of nights. But before we were able to do that, one thing we did is get agreement from the current, well, previous Cocotb primary maintainers, Stu and Chris, to share the load a bit more widely. And we did that after some internal discussions by proposing a pull request that added contribution guidelines. So these guidelines are still there today and outline how a patch should be accepted, how many people do have commit rights to the repository, what should be done, what is the quality bar, and what is the general process of merging commits. So now we have a clear set of rules that a small group of maintainers can follow, and we have agreement that as long as you follow those rules, any of those maintainers can actually merge a pull request. So now we have reduced a single bottleneck from having only one or two people who are actually able to merge pull requests and them agreeing on what the next steps of the project should be, to spreading that load out more widely. So this was kind of the most important first step. Then, as I said before, had to catch up, and one great way of kind of structuring a problem and making it more easy to manage is adding labels to GitHub issues and pull requests. And that's actually fairly trivial, but also very powerful feature of GitHub. You can define arbitrary labels and just attach them. So they can be categories, they can be priorities, they can be things like, oh, we need more input there, or we need input from a specific group of people here, or please, let's get back to the original person who opened the question, if there are still follow-ups, or if it can be closed, things like that. Also, Stu at this time did take a lot of the changes they had internally in-house and posted them as pull requests, so we got them merged as well. With all that done, we got a first release after many, many years of Cocotb release. So that's 4 years after the last release, we had a Cocotb 1.1. That's kind of the milestone when development picked up in more regular intervals again. So what did we do in the first release? And that's apart from the release notes, and already shows how much backlog there was. It was 25K lines of code that were added, in certain kind of growing overall 20K lines, 180 issues, 124 new issues that were opened, and a fair amount of pull requests. So that shows a first step into getting back into a more stable and predictable release process. And we kept it going. So 1.2 was roughly 6 months after that, in July 2019. And this was one of the first releases where we did pick up a fair amount of backlog on things that people wanted, but we couldn't get in because we didn't have the bandwidth to actually do the reviews. So Cocotb with 1.2 is now, for the first time ever, a Python package. And that is something that is essential if you want to have an ecosystem that builds around Cocotb. So now for the first time, you could do a package that depends on Python and just add a depends Cocotb to your setup.py, and it will pull that in automatically. So you were able to benefit from all the packaging infrastructure and the distribution infrastructure that Python provides, and use that. So that was a massive milestone. It actually took a fair amount of work to get there. There were also some changes to the Cocotb syntax. For example, async and await was now supported for the first time, getting Cocotb syntax more in line with more modern Python 3 ways of writing things that are similar to Cocotb coroutines and asynchronous programming that has become much more popular than it was initially when Cocotb started. So nowadays, many people know about Node.js and the way JavaScript and the asynchronous models work. And so things that were seen as rather obscure and weird when Cocotb started are now much more common. Some things that were enabled is just making syntax easier and cleaner, things like that. Further improvements that were not really seen on the outside, but were massive rewrites internally. We did have massive cleanups to the scheduler that were cleaning a huge amount of corner cases that it had. Exception propagation, huge documentation cleanup, and lastly, and that's kind of very important in the context of this talk, is Cocotb moved from a GitHub namespace, Potential Ventures /Cocotb, into Cocotb. So Potential Ventures was the company that Stu and Chris had founded to actually finance some of the Cocotb work that they have moved on since. And now Cocotb got its own namespace, indicating also that it's kind of slightly more independent, and it's a community and a project on its own. What we see in that slide with those changes, many of the changes are additions to what was there already, alternative syntax to a syntax that was there previously. So the previously coroutine decorators are still working, but just the async stuff came on top of that. Also, all the internal cleanups that we did were effectively all backwards compatible. We were kind of improving Cocotb internally, but still allowing users to upgrade from 1.1 to 1.2 without rewriting all the verification code. And that is a very, very painful at times, but very successful and I think necessary way of improving a software like Cocotb. Is you need to be able to find a way to gradually improve your software, to gradually move on and taking the users with you. Nobody will rewrite all their test benches after a year or two just because Cocotb maintainers thought, oh, there is now the fancy new way of doing things. There are good reasons to improve software, and software that is frozen, as we have seen in the past, is dead. So you don't want that either. So there needs to be improvement, there needs to be change, but that change needs to be managed, that change needs to be gradual, that change needs to carry users with them. And deprecations are a well-established and really well-working way of doing that. So what we're doing in Cocotb is making sure that whenever we remove or plan to remove something, we were adding a deprecation warning ahead of time. So these were sometimes just in documentation, but most of the time, those deprecation warnings were visible and are still in code. So when you ran your test bench with the newer version of Cocotb, it shows you log output that says, well, this feature that you're using here in this line is deprecated now. How about rewriting this piece of code to this newer syntax? And then the deal there is, don't ignore those warnings, but deal with them, but you don't need to deal with them today. So deal with them in your spare time, but don't just ignore them for the moment, because they will enable you to move on. They will enable you to, when the next release is coming out, to actually upgrade to that as well. But doesn't force you into those flag day decisions. Before we can upgrade, we need to sort through these things, or we upgrade and have a completely broken test bench, and now we need to figure out why. It doesn't always work, but it works in many times. We're moving on. Cocotb 1.3 in January 2020. So again, roughly 6 months. And one feature that was added there is support for very later. And very later just, well, being on the one hand just a normal simulator, and Cocotb has and does support a fair amount of simulators, but very later is also special. It's special in a variety of ways. It is special in that it is the only open source simulator that supports a very, very large set of synthesizable system Verilog. So it has the definitely best system Verilog support out there. It had very limited VPI support, which is what we need to talk from Cocotb to a simulator. And it's also an interesting showcase because we know of a fair amount of people who have tried to couple very later and Cocotb in the past and have gotten something working. What nobody did until Stefan, who is just hosting the session today, kind of took things in his hand, is combining those efforts and upstreaming them. So what was happening in the past is that at least 2 or 3 people and companies were doing roughly the same work again and again, but nobody was able to push things over the finish line. And what getting things over the finish line in the end meant was mostly changes to very later to improve VPI support, some smaller changes to Cocotb itself. And in the end, it wasn't that much code. It was probably a couple hundred lines, if so, to get all of that working. But now that we combined all those things and actually pushed it upstream, now everybody can benefit from it, and we don't have to duplicate that work again. So having a central place that is spending time and effort on reviewing, on going beyond what you actually need for your single use case, for your single problem at hand, and then pushing things upstream and getting them polished and integrated greatly helps everybody. But it is a fair amount of work, and we need to find ways to reward that investment somehow. We did, with the Cocotb releases that we had, we knew kind of from anecdotes, from talking to people, from hallway discussions, that a lot of people are using Cocotb. They're using it internally in large projects or small projects. They're using it at home. They're using it at university or other academic institutions to test out and verify chips. Mostly people who are either fed up with UVM or find the learning curve too steep. For example, if you're in an academic environment, looking at the whole UVM class library and getting started in UVM and constrained random verification, it's probably not something you want. You want, in the end, produce a paper, and you want to produce a paper in an efficient way, and you don't care about 100% coverage or things like that. That's for the industry, as we say now. So we wanted to get a bit more data on who actually is using Cocotb. What we did is a user survey that we sent out, and we got 110 people to respond, which I find quite interesting because, as we know, we get spammed with surveys regularly, and I tend to ignore most of them. So actually getting 110 people to respond was actually very, very good exercise. And we used that to determine better where to spend effort on time on. So for example, what did we get out of that? And that's just a tiny bit of data from there. Is we did have a question there, what version of Cocotb are you using? And at that time, version 1.3 was the most recent one. So that's roughly 70% of users were using that. But then we do have a reasonably long tail of people using older versions of Cocotb, 1.2, 1.1, and remember, 1.1 was and 1.0 was like fair amount of time before the 1.3, so multiple years. So if people on 1.0 at that time had a problem and would raise an issue or post a pull request to change something, they would be working on a code base that was 3 or 4 years out of date. So it is very likely that most of the stuff that actually they were worried about has changed in the meantime. So giving support to those users is very, very tricky. So that's something we don't want, and that's something that worried us. That's something we, for example, with those deprecations are working on, and there are other ways to actually work on that as well. More interesting data as well that we got out of that is another question on the top left. Have you ever reported an issue to Cocotb? And 60% have never done so, and 40% did. So that indicates, I think, for one thing, that most people that were reached by that survey did we did communicate them and did already have a working relationship with them through, for example, issues. But many people are just using Cocotb without ever getting in touch with us. A surprising amount for open source project, and well, even more for a commercial project, if it would be, is how many people have contributed code. 23% of the people who responded to the survey have ever contributed code, which is actually quite massive. So most people who use, well, not most, but a quarter of the people who use Cocotb still are also developing on it. I don't want to know how many people who use VCS have ever developed a line of code for VCS, change the tool itself. And something that I find personally quite interesting, around 30% of people who use Cocotb are not involved in any other open source project. So what we do in Cocotb is an entry door into the world of open source for a third of our users. So we can't expect them to know how communication in many open source projects work, something I take for granted because I've done that for years. But a third of our users have never done that before. So you will get interactions that are potentially not as the established open source norm might indicate, and there's a lot of teaching and learning to be done. So these are just examples of what we got out of that user survey, and there's a bit more in there. And we found these data points very, very helpful to move on. And we did move on, 1.4 release in July 2020. And one of the main concerns that we saw in the survey that we addressed there is making Cocotb easier to install. Cocotb, just a tiny bit of background, is using compiled libraries to talk to simulators, and these libraries need to be simulator specific because every simulator has a bit of special quirks in there. And installing and using Cocotb initially required a C compiler to compile those libraries whenever you started a simulation. So what we did is change the installation path to do that at installation time, as one would reasonably expect. And beyond that, there was a fair amount of restructuring in the way simulations and Cocotb itself is built. One other major thing that happened in that time frame is that we added our first proprietary simulator to continuous integration. A key challenge that we have in Cocotb is that it interfaces with many simulators. Some of them are proprietary, some of them are open source. And testing proprietary simulators is obviously something that you can do, but you need a license for that. What is established practice in most open source projects, that every change you do runs through continuous integration. It's tested against the environment it needs to be working in. And with Cocotb as a key selling point, providing that integration with other simulators, you want definitely to test that. But the only testing we could do is reach out to users who were, for example, having an LDEC license or VCS license or some other licenses, and say, please manually run the test suite or run your in-house code. And if you find something odd there, please report a bug to us. What we, in this time frame, could do for the first time is that we got approached by LDEC, and we worked with them to get access to a license. So they donated a license to us that we can use to run Cocotb in continuous integration. And now what happens is that every pull request that anybody does against Cocotb gets run against LDEC in a secure and shielded environment, and we get the test results out of it. So this is something that might be a bit odd for people who are kind of used to other open source projects. But what we need to do is we need to make sure that we don't give away like the license for the LDEC simulators for people to run arbitrary code on. So this is only to test this integration against. So we need to protect this license and the environment from kind of malicious use. And what we do have an agreement on is to run those tests in a way that the maintainers can see the test results and can see all the test logs and things like that. But the binaries and the detailed test logs and things like that are shielded from the general public. But what they see is still a pass or fail for all those tests. So that's already providing a huge amount of benefit to the community at large, and also providing a huge amount of benefit for all the users who use Cocotb together with LDEC, ensuring that whenever we do a change to Cocotb, it doesn't break existing support. So that's a win-win situation for both sides. And we're currently in process of expanding that partnership to other simulators as well. Cocotb 1.5 was then released in March of this year. So this is the most recent one. One feature I kind of particularly like there, it's just a small improvement in the end because it's building on top of what PyTest already does, is assertion rewriting. So if you have a piece of code that looks like the test code up here, so you assert that the D-out signal of your device on the test is matching some expected output. And both of them are variables. And if you just get a assert failure in here, you would say left side doesn't match right side, but you wouldn't know what the values actually were. That was what Cocotb 1.4 would present. For Cocotb 1.5 now does, that's the code snippet on the right side, is that it actually gives you the values those variables or signals did evaluate to, and shows you in this case that, yeah, binary value 101 is not equal to 100. So that's huge in productivity. So I particularly like that feature. But we did much more. There was work to enable compilation with Microsoft Visual Studio on Windows, always being an interesting topic to talk about. Windows support, kind of one of the recurring pain points in developing Cocotb. We did also do one thing that I'll get back to in a second, is we did factor out some bus components. So Cocotb did come with AXI and some other bus agents of some sort packaged within, but we couldn't really maintain it. We didn't have a personal use for most of them. So what happens is that we did ship them, but they were slightly broken, and people then kind of next to them wrote their own stuff. But we also didn't have the maintainer power to kind of help out and help improve those things. What we did is split out those components into a separate repository to allow them kind of to form a kind of small separate sub-community of people who are particularly interested in, for example, SPI or interested in AXI or things like that, should then come together and build a bus driver, a bus agent that works best for them. And that's when you have kind of the experts working together without others getting in the way. Recurring theme, obviously, is documentation improvements. We did that in this release as well. So we did learn a lot of stuff in the time we did these changes. Let's have a look at some of them. First, it's important to keep the maintenance work fun. So that's the list we've seen before, maintaining software and software projects and a hardware project. Like Cocotb is a lot of work. And if you're doing that in your spare time, as almost all of us are doing, you want to keep it fun. So you might want to pick up like 1 or 2 of the boring tasks of that list, but always make sure that you also pick up some of the exciting tasks potentially at the bottom of the list. And the way to do that is sharing load, making sure that not everybody, not one person or not 2 people need to do all of the things on the list. And we did gradually expand the list of maintainers. So we started with Thomas, me, Luke, Julius, Stu, and Chris, with mostly Thomas and me in the end being most active. And then we gradually added more amazing community members who were very active and using Cocotb and were proposing significant changes in pull requests and giving feedback to users in issues and discussions and things. So we added Eric and Colin, Caleb, and most recently Marlon to the list, and I'm pretty sure we'll expand that list going forward. And we'll also drop some people if they kind of move on, which is just normal and happens in life. We also did invest a lot in automation, and that's something that every project should and has to do if they want to be successful and stay relevant. Continuous integration is something I mentioned already. Takes away a lot of work from reviewers. Look into bots for issues and discussions, and look into third-party integrations. Let's have a look at a couple examples. For example, on continuous integration, the list of tests that run on every change to Cocotb is quite impressive these days. So we run against different versions of like Icarus and other simulators. We run against different compilers that people might be using, against different Python versions. So there's a fair amount of build matrix that needs to be covered, and still not exhaustive, obviously. And we run, and that's something I've shown in the past, is run all those tests against LDIC as well. And as I said, there will be other simulators coming on that list in quite recently, actually, quite soon. We try to automate things that are boring maintenance tasks as much as possible. So, for example, it is quite common that people ask a question on a GitHub issue, and then we never get the feedback if that actually the answer did resolve the problem. And we don't want to be super aggressive and just close all issues immediately, but want to give people a chance to follow up on questions. So we do have a bot that closes issues that are dormant for a while automatically. There are a huge amount of integrations out there in the world that you can use, and these are typically services that are free for open source, and you can pay for on-premises versions of them, and like Cocotb providing code coverage analysis and dashboard tracking, tracking of those things. And that's something we integrate. For example, every pull request indicates if that pull request increases or decreases the code coverage we have in our Python code. So all those things make it easier for maintainers to then approve or kind of give feedback to a pull request, because we already know we don't need to take care of the boring checks. We don't need to look if there's a test for that new feature, things like that, because that's something that automation already has a look at for us, and we only then need to look at the more substantial items, making overall the merge experience much less painful. One of the things that is something that is very close to my heart and something that we found immensely valuable in the Cocotb context is the aspect of an umbrella that you can trust. And to explain that, let's have a look at some of the things that you need for a project. And some of the, well, obviously the code as it is out there, it's, in Cocotb case, it's BSD licensed, so everybody's free to take it and distribute it and upload it in a different GitHub repository. So the code is free to be used and distributed. But there are things that are owned by someone. Domains, trademarks. These things need to be owned by someone. So who owns them? Do you want to have a single company owning them? And if they move on or do something else with the trademark, will the community be able to follow, or just will the project get abandoned and you need to fork it and start over? So what is helpful there is giving those things that need to be owned a trusted home somewhere that is representing the community, and that's the tricky part. But you also need a legal entity for some other reasons. So there are contracts in place, for example, getting access to those like simulator licenses and other things like that. Do need legally binding contracts and somebody who takes care of them, somebody who is able to sign them ultimately. You need money at some point, for example, like the continuous integration that we run there. It runs on private AWS instances, so somebody needs to pay for them. And if you're just doing this as an open source project where everybody just throws in a bit of time, it's fine. But there are some situations where you need actually real money. And you need fundraising for that, and you need to have sustainable sources for that, and things like that. And the reason why we founded Cocotb, founded the FOSSi Foundation, is actually to give an answer to all those questions. So, FOSSi Foundation is a community interest company. It is community owned. It is a non-for-profit, and we, as a FOSSi Foundation, make sure that the trademarks, the contracts, all of those things are moving along with the community. That if the Cocotb community, as a very undefined mass of things, if it decides to move on and do things differently, that actually the trademarks can move with them and don't stay with a particular company, a particular person, who very rightfully can choose to do something different, move on, do something else. But yeah, having the FOSSi Foundation there is a fantastic way to safeguard those assets in the long term in a sustainable way. Moving on, something that is essential if you want to be successful as an open source project, and that is very hard to do and very easy to state, is be friendly in your communications. We have seen in the past that like 30% of the people who are using Cocotb have never don't use or contribute to other open source projects. So the norms that have established themselves in this ecosystem, this not niche anymore, obviously, of the internet is not universal. So we need to explain things all over again, and that's expected. You can't expect that everybody knows that there is a contributor guide. You need to point people to that in a friendly way, and because yeah, that's just the way to do things, and the way to then transform those users into potentially people who contribute code, contribute useful bug reports. But there are limits to friendliness. There's you will always find users who come with a very interesting kind of demand, say, please implement this for me, or don't even add the please to that. And these are the cases when there is the need to say, well, no in a friendly way. And that's something that takes time, and that's also at times painful, and it hurts at times. But it pays off to be friendly and welcoming in all instances, and making sure that this is a project that welcomes all kinds of contributions. Because people, even though the first discussion might sound at times kind of harsh, often those kind of people then become useful contributors and actually are able to contribute back to the project. And yeah, communication styles are different all across the world. Make it easy for people to contribute, document how to do that, and encourage pull requests. If people come with an issue that is easily resolved by just changing a line or two, encourage them to say, oh, just do a pull request here. I'll guide you through. I'll help you. It's not scary. You'll manage, and I'll help you. And then this is often the first step in getting larger contributions from these people and growing the community, which is effectively the thing that, again, shares the load and makes maintenance easier. And as last item here is build an ecosystem. Don't try to do everything on your own. And we've seen that with the bus example. We did decide that we can't go with a full batteries included version of Cocotb because we can't know about all possible bus implementations. We can't reasonably review or pull requests that deal with the details of AXI. So build an ecosystem, allow others to independently make progress and not depend on you, depend on your reviews and input and feedback all the time. Keeping users close is something that is very, very hard to do, but very essential. So what you want to do is that all users run the latest unpatched version. That is the goal, but is almost an impossible goal. But there's some ways to get closer to that. Use semantic versioning, like a point release is something that is not expected to break existing test benches. A major release is expected to do so. Invest in deprecation and upgrade path. This is very, very painful to do in reality, because many changes you can do have side effects that you haven't thought about, and people will use APIs in ways that you never thought they would be used. So people will come back and say, oh, I actually was using this very weird, obscure feature. And we've seen that like with the 1.5 release, where we did 2 follow-up releases to change some things that we thought nobody was using, but turns out people were using it, and release frequently to make sure people are actually able to follow you along. We're not done yet, so there are things we will look into in the future to actually move on that path of making Cocotb a more stable and maintainable platform. We will be doing a major release, so this is something we haven't done in the past. All releases so far have been at least mostly backwards compatible. So there will be a major release. There will be some flag day changes that people will need to do, and this will be an interesting challenge in how we can make it as easy as possible for people to follow along and follow us on this path of this new major release. And we are looking into ways to make large changes easier to agree on. Making small changes is typically easy, but agreeing on large changes, like a redesign of a scheduler feature, for example, it's much harder. To summarize, the community is where the value is. That's the thing you need to be, you need to care about, and that's where most of the effort of maintenance goes. It's not into writing code. It's about documentation. It's about sharing knowledge. It's about automation, and it's about improving the small and little things that are potentially painful for people to get started. And if you do all that, you get rewarded. And that's one slide from the user survey that we did in last year. It's how likely are you to recommend Cocotb to others, with 5 being the yes, totally a best answer. So we see a overwhelming majority of users are enjoying using Cocotb and will recommend it to others. So this shows us that we're on the right path. Cocotb is the right thing. We're doing the right thing. And the path that we have been following and that we are planning to move on is the right path. And that is actually a very rewarding outcome of that survey that we got there. If you want to learn more about maintaining software and hardware projects, there are a couple items that I'm just mentioning here. So there's a best practice open source guide, and there is a actually very, very interesting book by Nadia. It's about working public and maintenance of open source software. So have a look at those. The last one is actually quite new, and it's a fantastic read. So thanks for all your attention. I'm open for questions now. and I'm looking forward to them.
Thank you very much, Philipp. Great presentation. There were a couple of questions and already discussions. Caleb was here to answer some questions already, but let us quickly go through them. I think the first one that everyone probably has is the question like how to get started with Cocotb. So what's the best way to get into it?
Yeah. So depending on the way you prefer to learn, there are YouTube videos out there of mostly me talking actually on how to get started on Cocotb. And this is kind of the video version of it. And the same, roughly the same content is also available in text form. If you head over to docs.cocotb.org, you find a getting started guide there, which guides you through the setup, which is typically the first hurdle, even though we make it as easy as possible. Kind of getting a working environment can be challenging at times. But then also on writing your own first test bench, getting the makefile set up and testing that on a very trivial example. If you don't want to set up the environment you own, I just want to give it a quick try. There is a link to Gitpod in the Cocotb README as well, so you can click on that, and you actually get a fully working environment with Icarus Verilog and a text editor, all of that in your browser right away without setting up anything. So this is actually a fantastic way of getting started without getting stuck in those initial setup hurdles.
Awesome. I think we should link the YouTube videos in the description below. So please return, watch it again, and go to the other links. Matt is asking, are there any training courses available? I think probably like commercial training courses or similar.
Not that I know of, no.
Okay, so that would be interesting if you're doing something like that. I think there's a sufficiently large user base of even like large industry players that use or plan to use Cocotb, and that might be interested in that. And that's already another question by Matt. Maybe you can say a few words about what big companies are using Cocotb.
Yeah, so that kind of ties in very nicely with the question about training. So we do know about a fair amount of big companies who are using Cocotb, and they are training their internal developers to use Cocotb because it's not standard UVM, so you can't go out there and buy existing training. So these training courses exist internally, but yeah, I don't know of a company that actually sells them like the Doulos does for UVM training, for example. Big companies that are using Cocotb, so it's very widely used in the FPGA world, and they are for example, in high frequency trading a lot. Most of these companies are very quiet about what they do, so we only kind of have very rough hearsay about what is happening there. We know that Broadcom, at least part of Broadcom, is extensively using Cocotb, and yeah, like TDK and others I've heard about using Cocotb. But again, like we do see in the user survey that a number of large names are popping up, and it is getting more widely used. But most of the time, since we don't have licensing agreements and don't have anything of that sort in place, it's really hard to know who in the end is using Cocotb.
Yeah, Caleb, I think, mentioned a few in the chat throughout the time that got, like sometimes you can see it by the question that they ask in issues, right?
Yeah.
What company they're working for. So Harun is asking, is Cocotb used commonly for system functionality at a high level using Python libraries only, or can it also be used for functional coverage closure?
It can be used for both. I think I guess there are two groups of use of Cocotb. There's the reasonably large group of users who use it for system integration, which is fantastic because it is very easy to have a golden model of like a larger design, a CPU, for example, that you have instruction set simulator for, and run that against Cocotb, because kind of tapping into that whole system of Python libraries and integrating that is very, very convenient. Also integrating, for example, your test bench against real measurements that you do on a signal analyzer, things like that are easy to drive with Cocotb and read out stuff from. So these things are where you really benefit from the Python ecosystem. But then, of course, it is possible to do kind of the low-level unit style testing in Cocotb as well. And that's where you very likely want to have constrained random verification of some sort. And there are Cocotb extensions out there that exactly help with that help with cover points and that help with constrained random. And yeah, just have a look for those extensions. They're actually very, very powerful, and a similar way of the way UVM is doing things. If you prefer to kind of go with the UVM terminology and the UVM class library, there are also ports of the whole, actually 2 ports of the UVM class library to Python, so you can carry that knowledge that you potentially have over to Cocotb.
This directly plays into the second question. Ignoring the learning curve part, are there any other areas where Cocotb is more suitable than UVM?
Yes, I would say so. And I guess the answer was already in the previous answer a bit. Rarely you do your verification in a kind of, you start rarely verification from scratch. So it's like you somehow need a golden model. You need something you test against. And if you are strictly in that's not so much UVM, but that's mostly a system Verilog. If you're in that world, what you do then is often interface through DPI, for example, with a golden model, with a simulation of some sort, with a C library that implements an algorithm of some sort. And doing those integrations is reasonably painful because DPI is just not a beautiful interface to work with. If you're in the Python world, it's just much easier. It's typically just import your fancy algorithm there and call it a day. So these days that you had to spend on getting DPI interfaces working and getting their bridging working, and they're all gone. It's beautiful.
Yeah, I think there's also this one of the large advantages, how easy it is to interact with the outside world. There's a large ecosystem that's already there compared to the pain you have to go through if you want to compile C and Verilog and everything in one environment, right? Is there any empirical data available on the performance overhead of Cocotb versus plain Verilog, VHDL, CPP test benches? Like there's some drawback in VPI and Verilog, very later I know. And are there any ongoing efforts on improving the simulation performance overhead?
There are general numbers about performance are always tricky because they're always wrong. So you need to effectively do some profiling. But there are some general things I can say. One of them is in the most convenient way of using Cocotb, you need to configure the simulator to give you access to all internal signals, which depending on the simulator slows down your simulation performance. So that's not something that is absolutely necessary to use Cocotb, but that is making Cocotb convenient, so you can make a trade-off there. The other area where you can optimize and you should optimize is reducing the number of interactions you have between Python and Cocotb. So if you, in the most trivial case, drive the clock from Cocotb, you have every clock cycle an interaction between the simulator and Cocotb and going back and forth. So no matter how performant the simulator might be, so this is an overhead because this is going to a different thread and things like that. So you can avoid that by, for example, generating the clock in your test bench already, and this is already giving you a huge amount of speed up. Depending on what you want to do, if you want to do unit testing, or if you want to do transactional testing on a bus, it is a good idea to go down to the level of only having a transaction being passed to Cocotb and passed back, and leaving everything else in the simulator environment and have it run there. But it is important to say kind of these optimizations are something that are easy to do, but they are in many cases not necessary for many of our users where we do have kind of Cocotb being used as the designer written test bench, the guy that writes the RTL as well and just wants to test it out. In those cases, you can just freely use the productivity and accessibility features that you get in Cocotb and don't need to worry about any of those optimizations.
Mm-hmm. Thank you. Oh, sorry. One question was if proprietary simulators mention Cocotb nowadays. So is there I think you spoke about Questa and others. Like, are they advertising it? And are there any efforts on making modifications to the tools to enhance compatibility with Cocotb, like going together with the Cocotb team, quoting Cocotb in releases, etc., and since when?
Yes, so we are being noticed, and we do see an increasing amount of companies who sell proprietary simulators actually getting in touch with us in various forms and ways. And the most advanced partnership we have in place right now is the one with LDEC, where we say, well, we test Cocotb against LDEC, and LDEC is also saying we do have this partnership with Cocotb, and they actively are telling their customers that the Cocotb is something that works really well with LDEC simulators. And as said in the past, we are having other partnerships of the similar sort lined up. So this is something that will increase over time. In terms of improving simulators to work with Cocotb, so Cocotb is not the simulator support that we need is not something that is special to Cocotb. It is industry standard VPI or VHPI or FLI. But then if you ever had a look at the system Verilog spec, it being industry standard still leaves a fair amount of space to implement things slightly differently. So we do see regular interactions between those vendors and people who are using Cocotb, and then there are typically also some of the maintainers to fix bugs in VPI and VHPI that are then, of course, usable to all users of these interfaces.
Mm-hmm. Then there was one question, if it's possible to run Cocotb on local machine. Caleb has answered it, but I wanted to bring it up because I know there has been some work on Cocotb in the cloud and running it like in a distributed way for large data sets, etc. Can you give an update on this?
Yeah, so running Cocotb on the local machine is the default way of doing it. So that's clearly possible, and that's, I think, what most people are using. If you then want to spread it out and do nightly regressions or longer regression runs, actually there's nothing built into Cocotb that does, for example, job scheduling or spawning of jobs remotely, but it is very well suited to just use the standard tooling that is out there already to do kind of solve those problems. And these are like, if you have an in-house Jenkins instance, or if you have a SO pipeline, so whatever kind of thing you might be using to do job scheduling and regression runs, that all works beautifully with Cocotb. The make files are set up in this way. We do report results out of the regressions in a way that is standard XUnit XML. So these are things that, for example, Jenkins and others can understand natively. So you get nice test reporting, you get success coverage numbers, things like that, out of these runs without doing anything on top of that. Something going back to the UVM question, something if you write your own UVM test bench, that's something you typically need to invest in or buy.
Okay, thank you very much. So that's it. All our questions are answered. Thanks everyone for attending. There were many thanks already on the chat too. Thanks for your presentation, Philipp. I think it was very good overview and insight about Cocotb and how it evolved. The next regular FOSSi Dial-Up will be 4 weeks from today. It will be Johnson Bolken presenting about Open Python, which is sounds a little bit similar, which is a massively parallel many-core processor. They developed at Princeton, and they, over the years, engaged more and more in the community, and we want to learn a little bit about how they did this. There will be some intermediate, shorter mini-series that we already talked about, hopefully starting 1 week from today, like next Tuesday, 4 p.m. GMT, around the shuttle run that we had around the Skywater PDK. So everyone who followed over the last couple of weeks and months, like already a year now, I think we've been doing FOSSi Dial-Up, and there were many presentations around the Skywater PDK and the open source shuttle, and we will see the first batch of results that came out now. And yeah, so please follow us on the website. You can find more on our website, fossifoundation.org, and please sign up to our monthly newsletter. Yeah, it's called El Correo Libre. I just wanted to say the word without, but it's Spanish, I think. And yeah, so I'm looking forward to speak to all of you again. You can find more videos on our YouTube channel. Please sign up so you get informed. I think you get notifications whenever we schedule a new event. And yeah, look forward to hearing from you. Start using Cocotb. It's great fun and productive. That's good. Good combination. Thanks a lot, Philipp, for taking the time. Thanks, everyone, for tuning in, and speak to you next time. Bye.
Bye.